Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to this Australian Water School webinar brought to you by iSwarm, and today we'll look at the interesting issue of lowering costs for water businesses. It's presented by Roch Cheroux, CEO of SA Water in Adelaide, South Australia. It's great to see you all here today. My name's Trevor Pillar, National Partnerships Manager here at iSwarm and the webinar chair today. I am so impressed. Every state in Australia and every territory and quite a few other countries, 18 or 19 other countries as well. Thank you all for joining us. It's quite impressive when you look at a map of the world like that and to see how many people are joining us today and talking with each other coming up in the future. A ton of free webinars and quite a few online courses and face-to-face courses. Encourage you to go to the website, get onto Twitter and find out how you can tap into those events coming up. There's lots more behind where they came from. Today, now, I'm very pleased to get right into the main game here. Roch Cheroux, CEO of SA Water. Welcome, Roch. So good to see you.
Thanks, Trevor. Thank you.
Let me do an introduction. Roch is leading the transformation of South Australia's largest water utility to embed technology, culture and systems changes to deliver improved experience for the corporation's 1.7 million customers, or many of whom are my family, I'd have to admit, but that's not the reason for my high support, Roch. It's purely the innovation and the can-do approach that you and your team take toward this. Let me move over here a bit so I can be seen a bit better. Roch's a key influencer in the water industry, experience shaping and leading public, private corporations across the Asia-Pacific region and in Europe. Currently the Director of Water Services Association of Australia and a member of the Australian Government's Australian Water Partnership Advisory Committee. And there's a lot more I could read there, but you can see his experience across the world, New Zealand, I see there Estonia as well. Terrific to have you today, Roch. Yeah.
Thank you. Thank you very much, Trevor. I'm not sure I deserve all the things that you say about me, but I'll try to keep the webinar interesting.
The results speak for themselves. I reckon there's a lot happening for SA Water, and we'll hear about it as we go through this webinar now. Right over to you, Roch.
Thank you. Okay, so let's start. So probably some words of background about SA Water. So it's a South Australian Water Corporation. So we are a corporation and we provide water and wastewater services for the entire state of South Australia. And interestingly, for some of our overseas participants, South Australia is actually the driest state in Australia, and Australia is the driest inhabited continent, which present us a number of challenges. In terms of numbers, we've got about 1.7 million customers in South Australia, a very, very long network because we don't have a lot of water, so we need to transport this water for over very long distances. So we've got about 27,000 kilometers of water network, which is a lot. And when you think about this length of network, actually, you already start thinking about pumping, and with pumping comes electricity. And that's why we had a number of discussions and pieces of work on what we wanted to do with our electricity bill, which is quite big, and I'll come back to that. And a few years ago, actually about 2 years ago now, or not far from 2 years ago, we decided to embark into a project that we've called our Zero Cost Energy Future. And this project is very much about the future and finding a way to be in a situation where our energy bill is actually reduced to zero. So it's a very ambitious project, but that's what we've embarked on. And I'll now talk a bit more about what we're doing to get to this future, this zero-cost energy future. So the context where we are, we're spending about $60 million a year in terms of energy bill, and that will vary between plus or minus $15 million per annum, which is the sort of variation. You've got a graph on the right hand side, which is an interesting one, and you've got here the variation of the electricity price on the market. Why is it important to us? It is important to us because actually we're not a very traditional water company, in a sense that we are buying our electricity on the spot market. So we don't have a contract or a number of contracts with electricity retailers, but we are actually a participant in the energy market in Australia, and we buy our energy on the spot market. So obviously when it's very expensive, then we don't buy, and when it's cheaper, then we buy. But again, I'll come back to that. So that's why the wholesale market prices have got a very big influence on our bill, on our electricity bill at the end of the year. And interestingly, so that's for all the electrons that we're buying, but we're also paying network charges to some of the network suppliers. And these network charges represent about 50% of our electricity cost. So keep this number in mind, because the network charges is actually a very important part of the business case that we've built to make the project work. So just continuing on our energy management journey. So I was talking about this journey and this decision that we made a few years ago to go towards a zero cost energy future. But it's actually not the first time that we had a deep consideration about what we wanted to do with our energy bill. And a few years ago, about 5 years ago, we actually decided to go from what we called energy procurement to energy management. So what we mean by this is that a few years ago, 5 years ago or so, we were in a situation like most of the companies in Australia and elsewhere, where we were procuring our energy from retailers and trying to find the best contract and the best options with a number of retailers. So you can obviously try to optimize this sort of situation by finding a better deal with another retailer, but it has a limit, and there's always a margin that you're paying to the retailer. That is a margin that is covering obviously profit, but also the risk that the retailers will take on your behalf. So we actually decided to move from this situation to a situation where we are actually managing our own risk, and this is what we call the energy management. The reason why we decided to do that is simply because we believe that we have a sort of natural battery with our network. If you think about a water network, and if you think about pumping water when you need it, but also pumping water when the electricity prices are cheap, so that you can fill your tanks or reservoirs or all the capacity that you have in your network. And then using this water that you've stored, but actually that is also energy that you've stored in your network when electricity prices are very expensive. And this is exactly what we've been doing during the last 5 years or so, where we've been pumping water when the energy prices were cheap, and not pumping water when energy prices were expensive. And to balance that and continue to deliver a world-class service to our customers, obviously we are storing the water in tanks or reservoirs if it's raw water, whilst energy is expensive. And a funny anecdote about the market is that sometimes actually energy prices are negative. And so that's it doesn't happen very often, but it happens from time to time. And there are situations where actually you get paid. We get paid to consume energy. So you can imagine that when it happens, that's when we start all our pumping stations and water and wastewater treatment plants, so that we are actually paid to consume energy. So that's what we've been doing for about 5 or 6 years now. It has delivered savings, millions of dollars of savings. But about 2 years ago, or a bit less than 2 years ago, we decided actually to embark into the next set of initiatives that we call our zero cost energy future. So it's built on the 7 initiatives, and I'll come back to that in a minute. But all this is actually building the capacity that we've got in the business about managing our energy portfolio. So this is where we are today. You've got the 4 of the initiatives that are currently used by SA Water to manage our energy bill. The first one, which is the demand response, is the one I just described before, which is basically being responsive to the prices that we've got available on the spot market, and making sure that all our operations is based on the energy prices. I need to make it very, very clear that it only comes second after customer services. So customer services will come first. And if we're talking about a booster pumping station, for example, the booster pumping station will be in operation, whatever the cost in the spot market is. So that's the first initiative, but that's a very, very significant one. Then we've got the biogas generation. So like many water utilities, we are generating biogas with our wastewater treatment plants, and we are using this biogas to generate electricity, and sometimes to use this electricity ourselves, or sometimes also to sell the electricity back to the grid. Our largest wastewater treatment plants are about 80% self-sufficient. So in itself, biogas generation is a big savings also. We've got also backup diesel generators that we have installed on a number of our facilities, water, wastewater treatment plants, pumping stations, etc. We are actually using this diesel generation not only in case of emergency, but also in case of high energy prices on the market. So it's also a way actually to save money in terms of energy bill. And then the fourth one is something that everyone does, which is about energy efficiency, and that's basically not only reducing the consumption of the different motors and equipments that we're using, but it's also using the energy in an efficient manner. So there are the 4 initiatives that are in place and have been in place for some years now, and as I said, have been delivering a lot of savings. What the zero cost energy future initiative is actually adding 3 initiatives to these 4 that we've got here. So the first one is actually increasing generation. And increasing generation is we could do it in a number of different ways, but we've decided to do it with solar panels. South Australia is a good place actually to generate energy from the sun, and that's why actually that's the most efficient source of energy that we found. But there's also the fact that this is a very modular energy source, and we can have a choice here if we use solar PVs between having a sort of big a big solar farm or actually having a number of small solar farms. And I will come back to that because this is a very important part of the business case. Another initiative that we adding to our portfolio is energy storage. So obviously, when you generate renewable energy and storage and solar energy especially, you need to be able still to have energy available at night when people will still be consuming water and will still need water and wastewater services. So energy storage is something that we need to have to ensure the continuity of service to our customers. But it's also something that we need to have to manage the price of energy on the spot market. So that's energy storage is another important component of our zero cost energy future. And the third additional initiative that we've got with Zero Cost Energy Future project is what we call predictive optimization and control. And I'll come back to that. It probably doesn't sound as important as solar PV and energy storage, but it's actually a very, very critical part of the project. And I'll explain a bit more later. So what are the key objectives of the project? Well, the first one is very much about our customers. We know, because we've been talking to our customers again and again, we know that one of the most important things for our customers is low and stable prices. With the variation and the uncertainty that we've got on the energy market in Australia, we needed to find a solution where we would have some control of the spend that we have in terms of energy. And this zero cost energy future will give us a lot more control compared to what we have today, with the electricity market going up and down in a very unpredictable way. Obviously, the project needs to be positive. The business case needs to stack up. And this is simply because we are a corporation, and not only we have an obligation towards our customers, but we have also some obligations towards our shareholder. Therefore, having a positive business case with a net present value that is not only positive, but which ensure a very good return was absolutely critical to the project. So it means also that not only we can control a lot more the prices that we will be able to offer to our customers, but at the same time, we will be able also to control a lot more the financial return that we're doing to our shareholder, the government. There's another aspect that is important, which is the water security. So the energy network is sometimes not as stable as we would like it to be, and we have some emergency situations where, especially some of our remote sites, where actually we completely switched off for the network for some time. So having the possibility to generate ourselves the energy to supply to our assets is an important part of improving the resilience of our services to our customers. And a subset of the project is that actually we're also providing a stimulus to the local industry with a large infrastructure project. So a number of benefits from this zero cost energy future project. So to come back to the infrastructure part of the project, two things. So we're installing actually a large number of solar panels. So it's 150, a bit more than 150 megawatts of solar generation. this is a lot. This is about something like about 500,000 solar panels that we are installing. And we are also installing about 35 megawatt hour of storage. So for the 154 megawatt of solar generation, we had a number of possibilities or options on how to invest this generation. One possibility was actually to invest into one large solar farm and basically get the electricity produced by this one solar farm. We actually decided not to go this way. And the reason why we decided not to go this way is because of what I mentioned before, which is the electricity, the network charges. As I said, network charges are about 50% of our total electricity cost. And the way to reduce the network charges is actually to produce energy on our side of the meter. And the solar panels, the solar generation was giving us the opportunity actually to produce energy on our side of the meter, therefore reduce the volume or the amount of energy that we're drawing from the grid, and therefore reduce the network charges that we have. So actually, instead of investing into one large 150 megawatt solar farm, we will be investing into between 70 and 80 different sites that are our sites where we've got the large consumption. So they are the large pumping stations, they are the large water treatment plant or the large wastewater treatment plants. And we will be investing on this 70 to 80 different sites on our side of the meter to not only generate, but also reduce the network charges that we are paying today to the network operators. For the storage, that's about the same story, because we will be splitting the 152 megawatt into 70 to 80 different sites. We will also be splitting the electricity storage into a number of different sites. And you have here a sort of idea. It's very high level, but it gives you an idea of the different sites and the different generation that we are installing at the different sites. So you've got a map of part of South Australia. It's only part of it, where you can see the red dots, which are the generation points. And they are the places, the locations where we've got the largest assets. And not surprisingly, a large number of the red dots will be around Adelaide, which is the capital city of South Australia. You can see on the left-hand side that we've got actually one very large site, and that's the desalination plant, the large desalination plant that we've got in Adelaide. And then a number of smaller sites that are the traditional water treatment plant, wastewater treatment plant, and the large pumping stations. So it gives you an idea of the spread of sites, not only in terms of geography, but also in terms of size. And as you can see, actually, we've got about 60% of our sites that are quite small sites. Now, I was talking about the economics of the project, and that's a definitely critical aspect for us. So when we worked on the project, we wanted to make sure that the project was NPV positive and that the return on investment was a good return on investment. But not only we wanted to do that at project level, which are the 70 to 80 sites, but we wanted actually each site to be individually bringing a good return on investment. So what we're doing, we're actually using a gate process where we're actually taking each site individually, and we will be doing quite a bit of work side by side to make sure that each site will provide a good return on investment, and that the net present value of each site will actually be positive. So that's the diagram that you've got here, very high level, but it talks about each site. And before gate one, there's no actually detailed design, and there's no Torquay's target outturn cost that we are discussing with our suppliers before it goes to gate two and then to execution of the project. So just to give you an idea of the level of detail, that we have gone into for each site of the project. This is where we are. We are a bit more advanced now. So this is about a week old. So out of the 76 sites that we are considering at the moment, 47 have gone through gate one, which is the go no go. 38, we've got the work pack issued to our contractor, and the concept design is on its way, and the TOC submission has been done for 5 sites, and we've got at this stage one site only, which is 12 gigawatt hour of energy that has gone to execution. So this is the project. We to give you an idea, we awarded the contract earlier this year. So this is very much the start of the project, and actually the timeline of the project is very, very challenging and ambitious, because we're trying to get as much done as possible before June 2020. Now, I wanted to come back on the optimization side of the project, because even if this is probably not the largest part of the investment, this is one of the most critical. And this is critical because we're dealing here with a lot of variable in this system. If you consider that you've got a lot of variation in the PV, in the solar panels production, simply because of the sun, the days and nights, etc. If you add to this the variation that we've got on electricity storage, how do we manage our batteries? When do they need to be recharged? When do they need to actually be used to power the different motors that we have? If you add the uncertainty that we've got on the energy market, with prices that are going from negative prices to extremely expensive prices in the same day, so with a viability that is very, very high. If you think about the viability that we've got in terms of network tariffs, because network tariffs are also changing. If you think about the viability of generation with our other sources of generation, biogas, for example. If you include to that the historic demand, which is the number of models that we're using to run the tanks, for example, the water tanks or the reservoirs on the raw water sides. If you think about the actual demand that we've got on the weather, on the network, and this demand will be highly influenced by the weather as well, but the weather will also influence the solar panel production. So you've got here a mass of parameters that will be highly variable. And actually, our human brains are not big enough and not strong enough to make the right decision in a timely manner. And just to give you an example, but on the energy market, the energy prices are currently changing every 30 minutes, but we're moving to a situation where we're changing every 5 minutes. And you can imagine the impact when you're moving from a price that could be an energy price that could be negative to an energy price that could be a few thousands of dollars per megawatt. It has a massive impact in terms of economy of a project. So we've got here the needs for an optimization tool to help us to manage all these different variables that we've got in this project. This is a combination of development that is done actually in-house because there's very little that we found available in the market. So it's a combination of things that will be or that are actually already developed and that have been developed in-house, and they will be integrated with a number of solutions that we're buying off the shelf from the market. Very interesting piece of analytics that we've got here. That's something that doesn't exist as it is in the market anywhere, and we had to build an optimization tool that is very specific to what we're doing. So that was one of the probably most complex challenge that we had to resolve with this project. This is, well, simply probably another illustration of the energy management system and the optimization system that we've got, where depending on the type of assets that we've got and depending on the variable that we can control, then we have to adopt a management system, an optimization system that is different. Just to give you an idea of what it looks like, so this is one of the sites that actually we developed as a sort of pre-project before starting the full scale project. So this is one of the main wastewater treatment plants in Adelaide, and you can see the sort of array of solar panels that we've got, and this is actually only half of the size of the solar panels array that we've got for this site. There is another one that you can't see in the picture, and you can see a small car at the back of the solar panels, just to give you an idea of the scale of the investment. A few words about some of the solutions that we are using and trialing. In terms of energy storage, so energy storage, part of our energy storage will be done using the sort of very traditional chemical batteries. So they are the sort of Tesla batteries that you can find probably a bit everywhere. But we also wanted to try different technology. And one of them is actually not chemical energy storage as the Tesla batteries, but it's thermal energy storage. So for the thermal energy storage, we've been working with a very innovative company, local company, actually Adelaide-based company called 14 Degrees. And the principle of this thermal storage is that you're basically using, so in our case, solar energy, but also biogas to melt a mass of silicone that is in the big box that you can see on the picture. So this mass of silicone will be molten by the solar energy or the biogas energy, and the energy will be kept actually in the molten silicone. So it's a different kind of energy storage, but very efficient. And when you need the energy back, you just let the silicone, or you help the silicone to cool down, and then you can get back the energy and then generate electricity. So what you can see here on the slide is the big box where you've got the silicone that is in molten state or in a solid state. And then you've got a big pipe, which is basically the air that is going through this big box, and that will get the energy from the thermal energy um, from the molten silicon, and that will then run a turbine that will activate a generator and generate electricity. So very innovative process. We've got actually the device or the asset that you can see here in the picture is now currently installed at one of our wastewater treatment plants, and we're starting the commissioning of this equipment at the end of this month or beginning of next month. So very, very promising and very interesting in the sense that a chemical storage, a chemical battery has a limited number of cycles. That's the same as for our mobile phone batteries. After some times, you need to replace the battery. The thermal batteries actually have got an unlimited number of cycles, which is, from an investment point of view, extremely interesting. And something else, one of the cool things that we've been doing is actually we've tried at one of the sites where we've got also solar PV installed. We've started quite successfully actually to cool down our solar PVs, simply because, as most of you would know, if the temperature is too high, then actually the generation of electricity from solar panels is not as good as when the temperature is cool. We've got very high temperature here with usually a few weeks over 45 degrees in summer. So cooling down the solar PVs is important and extremely efficient. So that's the project. In terms of time frame, you've got here the time frame. Again, very ambitious target to be there by 2020. Actually, we are on track. So at this stage, we're progressing, and you can see that actually you had in 2018 already some initial sort of test projects where we worked on the feasibility of the project before starting it full scale. So I think that's the presentation, and I'm happy to take any question.
Fantastic. What a great rundown of the innovation that is going on for SA Water. It's been absolutely fantastic. I can't say any more. There's a ton of questions here, Roch, and thanks for the time on this. It's been really good. Keep questions coming, people, but let's get underway immediately. I don't think there's anything else I want to look at, but there's a ton of people here listening, and there's a lot of questions. Phil Woods in, I believe it was Sydney Water, is that right? Yeah, Phil, that's right. Yeah. He says, do you put a dollar value on the increased electricity price certainty? Is this needed to get a positive NPV for the program?
So the answer is no. In the business case, we haven't put a dollar value on this. The business case is based on two things. The business case is based on reducing our costs, and the way we reduce our cost is simply because we are reducing the network charges, and we are also buying less energy from the grid because we are producing our own energy. So that's the reducing our cost part. And then the other component of the business case is that actually we increasing our revenue with the energy that we're selling back to the grid. So they are the things that are building the business case into a positive one.
Oh, that's great. That answered another question I had on my pad here. Are you participating in the grid and buying and selling energy?
Yes, so we will continue to be an operator or market participant, an energy market participant. We continue to buy some energy from time to time, and we also continue to sell energy a bit more than before and buy a bit less than before. But yes, we continue. It's not about being completely self-sufficient. It's very much about making the best out of our ability to generate energy.
Michael Young, also from Sydney Water, has a question: is the LCOE, levelized cost of E, expenditure? No. LCOE of the thermal storage solution comparable to battery storage?
It's that's actually a very good question. At this stage, we probably don't yet have the answer. Simply because what we've got, it's a significant prototype that we've got installed now. It's a 10 megawatt hour prototype, but at this stage, we don't have the final sort of industrial product.
Yep. No, the good answer. And this is the phase we're in. It's reasonably new, what is happening, and you're always going to be working on things. Yeah, so that's great. It helps everybody. Yeah. Honey Joseph is the energy manager at Lower Murray Water. I'd like to hear the life cycle asset concept engineering. I'm not sure of this, adapted for a zero cost energy future and the risk factors considered for energy resilience. You might be able to see that on your Q&A window.
Yeah, so I think the project, I guess there is probably two components here. In terms of energy generation, there is quite a good sort of return of experience on solar panels now. We are targeting a life expectancy for solar panels which is between 20 and 25 years. And for the electronics or the electrical part, which is the inverters, we're targeting something like a 10 years lifetime for this part of investment. Batteries, there's still some debate about the thermal batteries, but the thermal batteries actually have got a very long lifetime, simply because there is this unlimited number of cycles. So you would have a sort of lifetime that would be the lifetime of basically the turbine that is generating electricity.
Yep. Next one comes from Rodney Ringe. Do you have a carbon abatement driver?
Well,
and are you retaining the LGCs? That's the other part of that question. Do you have a carbon abatement driver, and are you retaining the LGCs from the renewable projects?
So that's it's definitely been on the table every minute we've been discussing about the project, but it's not a driver. It's more a consequence.
Yeah.
So the fact is that instead of buying energy from the grid that may have been generated with coal-fired power plants or gas-fired power plants, we now have a lot more green energy in our balance. So the fact is that we will be buying a lot less fossil generated energy, a lot less, we will be producing green energy. And by producing green energy, actually, we're also producing green certificates or renewable energy certificates that we can actually sell back to the market.
Yep. No, thanks, Rodney, from SEQ Water. Another one here from Jörg Keller. Hi, Jörg. Thanks for joining us. We were in a conference last week somewhere. Anyway, that's good. Jörg says, are you also using some of your energy assets to provide network stability services similar to the Tesla battery instead of just storage, which could be valuable to the network operators and hence generate some financial returns?
So the answer to that is yes. Some of our assets are quite remote, and actually by doing what we're doing, we will increase the stability of the grid in South Australia.
Yep. And one here from anonymous attendee: wind energy has the lowest cost, LCOE, of a new build renewable and produces during the night as well as day. You can see what it's going to go in all weather. Well, when it's windy, were wind generators ruled out of the investment criteria?
Well, at this stage, and I think we need to keep in mind that this is a project that is a very project that's not been done before, so things can change in the future. But at this stage of the project, if we wanted to be able to generate energy on our side of the meter to reduce our network charges, then we needed to have a very modular generation capacity. And wind generation was not giving us this sort of very modular capacity and was not making the project economically viable.
Yep, that's good. Yep. Bill Pemberton from Melbourne Water, as project scientist at Melbourne Water, has said, with the TESS, is the waste heat after generation used to dry biosolids on site?
Yes, so that's a very, very good point, and the answer is yes, meaning that with the thermal energy storage, not only we are able to generate electricity, but we are also using the thermal generation or the heat that is coming from the equipment to heat our digesters that we've got on site. So yes, you've got the two benefit of these solutions, which is heat and power.
These are great questions. We're pounding through them. We've got 10 minutes left, but let's keep going here. Caitlin Launch from Icon Water in Canberra has said, I'd like to hear more about the optimisation process that you went through. Did you already have the infrastructure, real-time SCADA, etc., to support that? And how did you develop the optimisation tool?
So it's the optimization. We had some optimization tool because of the fact that we've been a participant to the market and we've been buying our electricity on spot market for about 5 or 6 years now. So we had an optimization tool that was designed to basically match the market and the storage, the hydraulic storage that we have in our network. But we're now getting into a completely different space where, in addition to the demand, in addition to the storage that we have in our water network, in addition to the electricity prices, we've got also now production. We've got production in the sense of solar energy production. We've got the storage in our battery. So we've got a lot more variables that are coming into the equation that we need to resolve. And therefore, our optimization model that we have is not sufficient anymore. And we need to actually increase the capability of our optimization model with these new variables that we are bringing to the mix.
That's a great question. Thank you for that. Steve Reddington, who's a energy carbon program lead environmental planner at Barwon Water, said, you mentioned the network charges are currently 50% of your electricity costs, and the projects will provide a significant reduction in this cost component. Do you think there's a risk that network charges will move from variable, that is kilowatt hours or demand, to a fixed access capacity price?
I probably don't have the answer to the question because I guess if someone would know what's going to happen in the energy market tomorrow, this person would probably be very very rich today. So I probably don't have the question. I think part of the project was very much to give us this stability. So having a lot more control about what we're doing, give us this sort of stability for the future in terms of cost. Now, there will continue to be some variable in the market in terms of network charges, in terms of electricity prices on the spot market, and we'll have to deal with these variables.
Yep, no, that's great, Roch. Yes, thanks for that question. I'll just remind people that the chat line's really strong now. My colleague Joel has put some links there to the Australian Water School YouTube site, the presenters profile site, and other online courses you'll see there. Just go to that chat line every now and again. We've got just a few minutes left. So let's go. Santosh Arial is a researcher in CSIRO. Why were the solar panels put next to the sea? That's a good thought. Thought seawater mist would deposit fine salt particles on the panels to be cleaned regularly.
Yeah, and that's why actually we've got these different trials where we are cleaning panels with recycled water. So we've got a number of different trials to avoid these sort of situations.
Yeah.
Same situation could happen in the northern part of the state where it's sometimes very dusty.
Yeah. By zero cost energy, this is from an anonymous person. By zero cost energy, do you mean just electricity, or is fuel, diesel, etc., petrol included in the zero cost energy?
No, we're talking about electricity cost, which is the majority part of our cost. We're not yet talking about electrical or electric cars, but that will come.
Yeah, that's for sure. Yeah. Another one anonymously is it possible to generate hydroelectricity by using the head height of South Australian water, SA Water's storages? So your up gravity, up gradient storages.
We're actually using some of it, and I'll take the example of the Adelaide desalination plant, where the desalination plant is actually 30 meters above the sea level, and when we discharge the brine back to the sea, we are actually generating energy with a turbine. We've got a few more turbines in our network in some of our facilities, but we've looked at the possibility to generate more. And again, the business case was not stacking up.
Yep. No, that's great. Yeah. Santosh has also said, what is the network charges and how does it differ from the energy charge per unit of power?
So the network charge is basically you could associate or compare it to a sort of connection charge to the network. So this is basically paying for the size of the cable that is connected to our facilities. So the bigger the cable is, and the more we have to pay, because then it means that the network operator will have to keep some capacity in their network to supply our equipment.
Yep, that's great. Aptu is with the Water Resources Department, Malang, in Indonesia. Does it mean when we use energy from the sun that it will be an expensive cost? Especially the water development sector.
No, actually, it's a lot. Well, every case is probably different, but it's a lot cheaper than having a connection to the network. I take the example here. For us, it was clearly the best solution and the most economic solution to achieve our zero cost energy future. But I'll take another example of what we do in the northern part of the states, where we've got some very remote communities where actually all our bores will be powered by the sun, and this is obviously a lot less costly than having to build a line between the network, which is sometimes tens or hundreds of kilometers away from where we operate.
I think we should take one last one, and we're getting to the end of our time here right now. There's just one here that's reasonably lengthy, but it's got some interesting bits in it. It's from an anonymous attendee. Taking on the risk part of energy management from outsourced from a specialist to insourced internally has a cost. Any savings you take to the retailer need to be spent internally on your own systems. Can you show the overall cost to customers for electricity has been coming down in recent years?
Yeah, absolutely. It's absolutely obvious. I think it's a good point, because it means that when we started to be an operator or participant to the energy market, we had actually to acquire very, very different skills compared to what we had in the business before. But we have an energy team that is composed of people that are coming from the electricity industry, and they are real specialists in what they're doing. But we had to build the capability of SA Water in terms of energy management. This is what we've done. But when you compare the overall savings by compared to where we were if we were still buying energy from a retailer, it's a massive difference.
Yeah, right. Yeah, I can't help. I know we're getting close to that 1 hour mark, but Craig Bagnall has just written a fantastic presentation at Roch. But then he goes on to say several water utilities in Australia are investigating pyrolysing biosolids. Has SA Water also investigated further recovering energy from biosolids to potentially go further towards a cost negative position?
We have looked at it. When comparing the business case of biosolids with what we're doing with solar production and storage, it was better to go towards the solar production. Now, again, I think it's very much depending on the situation of different water utilities. So what we're doing today may not work with another water utility. For example, if we would not have the land that we need to install the solar panels, then most probably the economy of the project would not work. But because we've got quite a lot of land and some of our facilities are quite remote, therefore if we don't have the land, we can acquire the land for a very cheap or cheap price, then that works for us. Now, if you think about a water utility that is a business or central business district water utility, the economy would be completely different, and what we're doing may not work.
Yep. Look, we're going to leave it right there. It's been a fantastic hour. I can see most of you stay with us for the entire hour. I want to say a big shout to the fantastic team here at iSwarm, Dr. Ian Reid, Michelle Haar, Joel Bortman, Claudia Afaro, and of course iSwarm's MD Darryl Day. They do a lot of the unseen work, so thank you to all of those. Thank you so much everyone for participating. There's a feedback survey coming up on your screen as you close off now. We're going to email the recording to you. Look at all those free webinars, courses, and face-to-face courses. We're loving it here. We're doing lots of it. So go onto our website, onto the YouTube, onto the Twitter address down the bottom there, and check them out. Thank you most of all, Roch, for your time today. We've hugely appreciated it.
Thank you. Thanks, Trevor. Thanks, everyone,
for joining us. See you next time. Bye for now. Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.